Hello. Today we are going to do. I'm actually going to break today's lesson into two parts because I think that doing too much at once is bad. So we'll get into that in a second. Have a go at the starter, and then we'll talk about it. Okay. So y equals. If I was going to draw y equals x minus 2, right, using y equals mx plus b, we know that you start at this number, so minus 2 on the y-axis, and then whatever the slope is, which in our case is just 1, right, or 1 over 1. You go this amount right, this amount up. In our case, it's 1 right, 1 up. So it looks something like this. So y equals x minus 2 would look roughly like that. Now, what's important here is we don't have equals, we have a less than sign. Because it's a less than sign, that means it's dotted lines instead of solid lines. So it looks like this. And then, I just went on yep, good. It looks something like that. Doesn't matter if you did that or not. And then what we need to do now is we need to shade one side of it. So either this side's going to be shaded or this side's going to be shaded. Now what we do is we pick a random point that isn't on the line, and we solve that. We substitute that in, and then if it works, we shade that part in. If it doesn't work, we shade the other part in. So for example, I'm going to pick. I know I already highlighted it here, but I'm going to pick 0, 10. So when x is 0, y is 10. So is 10 less than 0 minus 2? No. 10 is greater than 0 minus 2, isn't it? 10 is bigger than minus 2. So because this point doesn't work, that means none of this area should be shaded, and it means that this place should be shaded. So it looks something like that. For x is greater than or equal to 4, we pick, for x equals 4, it would be a line that looks like this. It's a solid line now because it's not. If it was that sign or that sign, we know it's a dotted line. But because it has an equal sign, we know it's a solid line. And then we're looking for all values of x that are greater than or equal to 4. Well, we have the line that's equal to 4. All the numbers that are greater than are going to be 5, 6, 7. All those numbers, aren't they? So this area is shaded for us because that's all the numbers that are bigger than 4 for x. Cool. As we talked about last time, you can, worst case scenario, type this into Desmos and get an answer, and it will show you roughly what I've shown you here. So worst case scenario, you always have that to back up, to have as a backup, but you don't, obviously it's quite important for you to just kind of understand it because it's important, like all these skills are useful skills, right? Okay, so on Desmos, have a go at these. Type in x plus y equals 7 and x plus y equals minus 1, and what do you recognize? What do you notice? So let's do it ourselves, shall we? Would have been nice if that came up like I told it to. Yep. So for x plus y equals 7 plus x plus y equals 7. If we have a look at here, I don't know what's happening with this graph here, like what's currently happening. We're going to just refresh the page, that's what we're going to do. There you go. Let's try it one more time. X plus y equals 7. If we have a look here, there it is, x plus y equals 7, right? What's really interesting about this is if you look at the x-intercept, that's 7. If you look at the y-intercept, that's also 7. And our line is x plus y equals 7. Now, literally, it's telling you that these two values, when they add together, must be 7. So if it's 5, then 5 is with 2, right? 5 is with 2. If it was 4, that's with 3, because 4 and 3 make 7. If it was 3, it's 3 and 4 make 7, right? So x plus y equals 7 is effectively telling you two values that add up to be 7. And even if we go even higher, right? If we go to 10, right, 10 should be with negative 3, shouldn't it? And it is, right? 10's with negative 3. So this is a new way of looking at a graph. So we're used to y equals mx plus b. And then now we have x plus y equals something. And effectively, it's ax plus by equals something. And so this is in the form of ax plus by equals c, where the numbers basically always add up to be that number. All right? So let's have a look. So what about these? What's interesting about this? 2x plus 3y is 12. Well, 2 times something plus 3 times something is 12. And what we can do is we can actually find out their coordinates for the x and y intercepts by effectively ignoring one of the letters, right? Because it's not really ignoring, it's basically making it 0. But if 2x plus 3y is 12, and I want to know where the x-intercept is, I can basically go, okay, 2x plus nothing, 2x is 12, x is 6, so therefore I know the x-intercept is 6. And then I can look at it again and go, okay, what would the y-intercept be? Well, if during the y-intercept, the x is 0, so I can bring this across. Stop that, please. And I get 3y is 12, y is 4. Divide by 3, right? And so by instantly finding the x and y coordinate, I can draw this incredibly quickly. So we used to, that's supposed to be a straight line, would you believe? We used to, for y equals mx plus b, we have a method there, don't we, where we look at b and then we use the m to find the slope and then use the slope. This method is effectively you ignore one of the letters and then you solve the equation like a normal equation. Let me put that into better words, probably. So, the x-intercept is when the y coordinate is 0, right? That is what the x-intercept is. What we do then, if we can just find the x-intercept by effectively ignoring y and solving the rest of the equation. The same can be done for the y-intercept. You just ignore x and then find out what the y coordinate is, right? These two values, this x coordinate and the y coordinate that you find, can then be used to draw the line. Let's do an example. So, x plus y equals 10. I'm literally going to ignore the y and get x equals 10. So then I can put a little dot here for x equals 10. I've just done it. I said x, didn't I? And then I did y, my bad. So, if I ignore y, I get x is 10. So then x is 10. Good. If I ignore x, stop that. Oh, please, keep. Why are you being a pain? Yeah, good. Yeah, end that. Good. Awesome. Yeah, good job. Well done. Really good job. Okay. So, if I ignore x, I get y as 10. If I ignore y, I get x as 10. Now that I have these 2 points, draw a straight line between them, and you're done. What about this one? If I ignore y, I get 3x is 24. If I divide by 3, I get x is 8. So my first coordinate, x is 8. If I ignore x, stop that. If I ignore x, right, I get negative 4y is 24. If I divide by negative 4, I get y is negative 6. So then I go to negative 6 on the y-axis. Now I have my 2 points. I can draw a line between them. Cool. Have a go at these 6. Wow. Have a go at these 6, and then that is effectively the end of the lesson. Okay, so x plus y equals 7. You should have had x is 7. Y is 7. Draw a line between them. A straight line would be lovely. What about 4x plus 6y is 12? Well, if I ignore x, I get 6y is 12, so y is 2. If I ignore y, I get 4x is 12, so x is 3. And I draw my line. And obviously, as always, our line should go on forever, ever. If I could draw accurately, that'd be crazy. Cool. What about y plus 5x is negative 20? Well, if I ignore x, I get y as negative 20. That's not actually on our graph. Let's pretend that's a negative 10. That'd be a better number. Okay, so if I ignore x, I get y as negative 10. Cool. If I ignore y, I get 5x is negative 10, x is negative 2. And then I would draw my lines up. What about x minus y is 4? Well, if I ignore x, I get negative y is 4. If negative y is 4, y is negative 4, isn't it? If I ignore y, I get x is 4. And draw the line. What about 3x minus 4y is 24? Okay, well, stop that. If I ignore y, I get 3x is 24, so x is 8. If I ignore x, I get negative 4y is 24, so y is negative 6. y and take away 2x is negative 8. If I ignore x, I get y is negative 8. If I ignore y, I get negative 2x is negative 8. So I divide by negative 2, I get x is 4. Draw the line, win the life. Okay, that is it for today. I'm splitting this lesson into two for a valid reason, I promise. So if that made sense, wonderful. If it didn't, please let me know. As always, have a good day.